Hello and welcome to SudoKanard. We're here to solve this arrow Sudoku by Italian author Valerio Stancanelli from the latest WPF Sudoku Grand Prix. It was worth 57 points and I would have put it perhaps a little higher, like in 65, 70. Not that it's an impossible puzzle, but I think it was more difficult than the other puzzles with a similar number of points. Well, so the special rule is that whenever you have a circle with an arrow stemming from the circle, the digit in the circle is the sum of all digits along the arrow, which means in this case that those are the same digit. And this is this plus that. And in the case of this pill, we have a two-digit number read from top to bottom. And this two-digit number is the sum of those four digits. So the first thing I'm noticing is that this is the sum of many digits. And if we try to make those digits minimum, we will have here 1 and 2. And here we will have 1, 2, and 3. And you can see that the minimum value of the sum is 9, which is also the maximum value. So this has to be a 9. And the 1, 2, 3 triple has this partial disambiguation thanks to the given ones. So that's the easy part starting the puzzle. Now, what can we see? The minimum value of those two now is 4 and 5, which means that the minimum value here is 9, so it has to be the 9 with 4 and 5. And here we're left with 6, 7, 8, 9. Well, I didn't pencil mark them when I did the contest, but I will for the sake of exposition. Here we have a lot of digits again. Here the minimum value of those is 1, 2, 3, and here it's a 2 because of that. So the minimum sum is 8, which means that this is 8 or 9, and we only have 1 degree of freedom. So this is either 2 or 3, and here the sum is either 6 or 7, which means that 1 and 2 are here, accompanied with 3 or 4, according to what happens in those two cells. Now, what about this? We can see that the minimum sum of those three digits is 21, plus this we are in the 20-something. So this is 2 at minimum. And what is the maximum value? Well, the theoretical maximum value is with 7, 8, 9, and 9, which is 33. Except that 33 can't be done, so the maximum value here is 32. And the interesting point is that this can't be 31, because there's a 1 here. So if this is 30-something, then it has to be 32, and if it's not, then the 2 is in here, which means that there is a 2 in one of those two cells. This is 1, this is 2. And that, I remember, was a hard part in solving the puzzle, noticing this. So this is neither 1 nor 2, and this is not a 2, so that's the 1 and that's the 2. And this is 3 or 4, according to what is happening around here. Now, this being 1, the minimum value here is achieved by 2, 3, 4, which makes 9, and which is also the minimum value, also the maximum value, sorry. Now, 2 is not available in here, so the minimum value is with 1, 3, and 4, which is 8, and 9 is not available, so 8 is also the maximum value. So this is indeed 1, 3, and 4, which means that this is finally a 2, and that's a 3, that's a 2. So this column still needs 5, 6, and 7. This 8 now tells us that this is a 9, So this, oh, and there's a 3 here, so that's a 2. We have 5, so this is 4. So the remaining values here are 3, 5, 6, 7, but this is the same as that, so it's not a 3. Those are from 5, 6, and 7, and this repeated digit is somewhere here, which doesn't really help. At all, actually. We have a 3 somewhere in here, so 3 is not there, it's somewhere around here. But this digit is the same as this, which is not 3, so 3 goes there. And this is not 4, so this is anything from 5, 6, 7, 8. We don't know which one at this point. And those are also from 5, 6, 7, 8. I don't think we can do a lot with this. We still don't know, we still have no clue about what goes there. So the total sum is still a great mystery. But then this is a 2, so 2 does not belong in here. So the minimum value is 1, 3, 4, which is 8. And then again, 9 is not available, so the minimum value is also the maximum. So this is with 1, 3, 4, that's not 1. And there, what are the options for this? The minimum value is with 2 plus 5, which would make this 7s, and the maximum is 9. And 9, without using those digits, will be with 2 plus 7, so we must have a 2. 7 is 2 plus 5, 9 is 2 plus 7, and so the 2 goes there. And this is 5 or 7, and in both cases we have a 7 here. So those are from 6, 8, and 9, and this digit is the same as this, and this is not. What was I doing? No, sorry about that. So we have 9 or 5 remaining, so those are from 5, 6, and 9, and this is 5, 6, or 9 repeated. Something of interest here is that this digit here, which is the other 3 or 4, must be somewhere in here, and it must definitely be the smaller digit because this will be a higher digit anyway. So we get a 3-4 pair here, which means that this is 1. And then what? Where do we look? 4 is not here, so in this region 4 must be there. What are the options for this? Well, a lot of options are still available, I'm afraid. What about this column? In this column we still need 5, 6, and 7. On this row I need the 2. 2 is not here, it's not here, it's there. We still need 5, 6, 7, and 8, which is not very useful. This is also true here and there. 1 can only be here. 5, 6, 7, and 8 in here. I don't remember what I found after this. Oh, there must be a 1 in this region. It can only be here. All right, that's interesting. So 1 is small, definitely. So now the highest sum we can make out of this is with 7, 8, 9, and 1, and that's 25. So that's the highest sum, but that's also the smallest sum. So this is 25 with 7, 8, 9, so that's a 6. And that's not 6, and that's not 6, so 6 is here. And 6 is not here, so 6 is not here. Oh, and there's a 5 here, so this is actually a 7. That's not 7, so 7 is here, and that's a 6 now. And this is a 6 as well. And this is now a 5. So the only option, that's not 4 plus 1, that's 3 plus 2. This is 2. Now this is 9, this is 7, this is 5. This is also 7, this is 5. And this is slowly unraveling. This 6 here goes there. Those are 7, 8. And this here must be the 9 inside this column. Those are 4 and 8, I think. Yes, oh, this 3 disambiguates all of that. Those are 4 and 8. And I'm seeing I have 2 instances of 4 in those 2 rows, so there can't be a third one. And actually this 5 disambiguates all of that. And this 9 disambiguates this also. That's not 7. So, oh, this is actually an 8 considering the column. So it disambiguates all of that. And the hardest part seems to be done. I still need 5 and 6 on this row. With this 6, that's the 5, that's the 6. Here the 3 is not there, that's a 5. Here I need 8 and 7, so 7 here, 8 there. Here I need 3 and 6. Here I need 4 and 5. So this is 8, this is 9, this is 4, this is 6, this is 3. And that's it. So that wasn't a monstrous puzzle, but there was some serious work to do. Not quite as difficult as the work we had, the logic we had to pull off in the half correct quadruple Sudoku, which was definitely harder than this. But I think that this was significantly harder than some other puzzles around the 60-point mark. I think it was significantly harder than the prime stuff, the prime number stuff. Where was it? It was here, 2-digit prime number, 62 points. I think this was much easier than arrow. But then, this is my opinion, and as usual, you're all entitled to a different one. Thanks for watching this video. See you soon on SudoKanard.